Welcome to aminacademy.com. In rotational motion, let us do some solving problem. Look at this example. Find the moment of inertia of a sphere with axis tangent to it. We know that the moment of inertia of the sphere about axis passing through the center is IC equal 2 over 5 into mr square. But we need to find moment of inertia about its tangential axis. That means, look at here. Suppose this is a sphere of radius r. Mi, that is the moment of inertia through center is IC equal 2 over 5 mr square. But we need the moment of inertia about the tangent axis, that is through the tangent, means that is we need IT is the question mark. Here this is a radius. By using parallel axis theorem, we know that IT, that moment of inertia about tangential axis, is equal IC, that is moment of inertia about the center, and mr square, where r is the radius of the sphere, which is equal mr square is common, then take out, then 2 over 5 plus 1 is 7 over 5. So 7 over 5 mr square equal to IT, that is moment of inertia about tangent axis. Next question. A car accelerates uniformly from rest and reaches the speed of 25 meters per second in 9 seconds. If the radius of the tire is 30 centimeters, find the number of revolutions the tire makes during this motion, assuming that no slipping occurs. Here the car travels in straight line, uniform, and speed is 25 meters per second in 9 seconds. That means it accelerates, and radius of the tire is given. Then find by using Newton's motion equation, v equal to u plus at, that is final velocity equal to initial velocity plus acceleration into time, where u equal to 0, initial velocity is 0. Therefore from this u time is 0, therefore v equal to at, then a equal to v over t is 25 over 30, time is 30, then 5 over 6 meter per second square. Distance is s equal to ut plus half at square, where here ut is 0, half, a is 5 over 6, and time is 9 seconds, so 9 square is, this calculation is 18.75 meter. Number of revolution is distance divided by 2 pi r, means the car travels this much distance, and the radius is r, the car, that is 2 pi r is circumference. So if you divide by, that is distance by circumference, we can get the number of revolution of the car, that is 18.75 over 2 pi r equal 9.946, which is equal, that is 2 into pi value, and r is 0.3, because the car radius is 0.3 meter, because 30 centimeter gives 0.3 meter. So we have 9.946, which is equal 10 revolutions. Next question. A cylinder of radius 20 centimeters is rolling along the surface with constant speed of 80 centimeters per second. That is, cylinder is rolling. What is the rotational speed of the cylinder about its axis? So the cylinder is rolling along the surface with constant speed. That means radius r equal to 20 centimeter, which is equal 0.2 meter, and speed v equal to 80 centimeter per second, which gives 0.8 meter per second. We know that linear velocity v equal to r omega, from that is omega equal to v by r, that is 0.8 over 0.2 equal to 4 radian per second. That is first question answered. Second one, what is the magnitude and direction of the acceleration of the points on the surface itself? Since there is no acceleration for the cylinder, that means it's a constant speed, so alpha acceleration is 0, and we have just radial acceleration, ar equal to A r equal to r omega square, which is r equal to 0.2, 20 centimeters 0.2 meter, and 4 square. Omega square is 4 square, so 3.2 meter per second square. Next, velocity at the top will be given as, we know that here Vt, that v equal to v plus r omega, then v equal to 0.8, r omega also 0.8, so it is equal 1.6 meter per second. Velocity at the top will be given as 0. Velocity at the top is 0 because at the top there is no velocity of the cylinder. Here next, a disc has a speed of 1200 rpm and it's made up to slow down at a uniform rate of 4 radian per second. Calculate the number of revolutions it makes before coming to rest. Here frequency, we know that 1200 rpm is given, divided by 60 means rps, that is 20 revolutions per second, because minute is given, second is converted. Now omega 0, initial angular velocity is 2 pi f, formula, that is 2 into pi, f is 20, then it is equal 40 pi radian per second. Omega finally is 0 because it comes to rest after the acceleration. Here alpha is minus 4 radian per second square because it is negative, because it is come to rest deceleration. Then omega final equal omega 0 initial omega plus alpha t. Then here omega final minus omega 0 divided by alpha equal to t. Then t equal that omega final is 0 because it comes to rest, and minus omega 0 over alpha. We are substituting the values, it gives 10 pi. Now theta, this is a total distance covered. That is total distance covered means omega theta angular distance, that is omega 0 t plus half alpha t square. You are substituting the values, respective values, omega 0 time and alpha and time square. We get theta equal 200 pi square. So far we have done these problems fast. Look at this one more time. Here first find the moment of inertia through the tangential axis we found. This question, Newton's motion equation we are applying, and find the number of revolutions we found. Third is cylinder rolling through the surface, no acceleration. From that we got angular velocity and everything we found what is asked. We have done. Please subscribe our YouTube channel.